In this video, I'm going to talk about the three different induced intermolecular forces. So I'm going to talk about ion-induced dipoles, dipole-induced dipoles, and London dispersion forces. But before I got into the intermolecular forces, I want to talk about a concept called polarizability. Polarizability is the ability to distort an electron cloud. And what this means is that there is going to be a charge separation. So a picture is a good way to think of it. Let's say before and after. Before, we just simply have a molecule. I'm going to draw it as that. And that molecule is just equal everywhere. There's no separation or anything. But polarizability distorts the electron cloud. So this is our electron cloud. And what will happen to it after it gets polarized is that it will develop two different poles. So you'll have a side that is electron deficient and a side that is electron rich. And you can just picture that as this. These are just the electrons flowing just to mostly one side, and this side is just empty. So whenever you think of polarizability, just think of charge separation. So the first induced intermolecular force we're going to talk about is an ion-induced dipole force. So it's basically an attraction between an ion and a non-polar molecule. Because if it was polar, it would just be an ion dipole force. What will happen in an ion-induced dipole intermolecular force is that an ion, which means a particle with a charge, will approach a non-polar molecule, so it will have no charges or no separation into poles, as we saw here. It will approach it and it will polarize it. It will distort the electron cloud and then just shift it. So this is what will happen. You will have, let's say you have a cation right here. It has a positive charge. And we had a simple non-polar molecule right here. So there's no separations. The electron flow is all around the molecule. Now, when this approaches it, what happens is that, so I'm going to call this step 1 and this is step 2. That positive charge will move the electrons away toward it, sorry, because it's positive. So it will move the electrons from all around the molecule to just one side. It will polarize it into this. So we have our cation here, and then the molecule will become this. It will become delta negative here, because the positive charge is right here. So this will attract each other, and then this side will just become delta positive, which is electron deficient. And that's an ion-induced dipole interaction. So the dipole is induced by the presence of an ion. And well, the opposite would happen if we had an anion. So the electrons would shift the other way. The second type of induced intermolecular force we had was the dipole-induced dipole intermolecular force. So in a dipole-induced dipole intermolecular force, there will be an interaction between a polar molecule and a non-polar molecule. So instead of the ion, as last time, we just have a polar molecule. In this case, that polar molecule will polarize the non-polar molecule and do the exact same as what happened in the last case, but in this time it's just two molecules with two poles interacting instead of an ion. So let's picture that again. Let's say we have two molecules right here, two electron clouds. This one is non-polar, and there's electrons flowing everywhere. And this one is polar, and most of the electrons are flowing on this side. So this will be delta positive, this will be delta negative. When this approaches this, the same will happen as what happened last time. The negative charge that is approaching the nonpolar molecule will shift the electrons away. So what will happen is, this is step 2 now, we have our polar molecule again, and this molecule will be, I'm going to label them A and B just to make it easier. So A is still polar, and B will polarize and become polar, as the name says. So because this side is delta negative, this side will become delta positive, and the electrons will shift this way. This is delta negative. I'm mixing the colors. I'm sorry about that. So we had delta negative right here, delta positive right here, delta negative right here, delta positive right here. And now there will be an attractive force between these two poles, and that's called the dipole-induced dipole intermolecular force. We had a dipole at first, and that dipole induced a second dipole, so molecule A induced molecule B to become a dipole. Finally, the last and third intermolecular force, induced intermolecular force I'm going to talk about, are called London Dispersion forces, and they are momentary distortions in the electron cloud of a particle. The first thing you should know about London Dispersion forces is that they occur to everything. Every molecule you can think of has a London Dispersion force. And well, for nonpolar molecules, London Dispersion forces will be the only present force. And London Dispersion forces are the weakest of the intermolecular forces. Because they're so common, they occur to everything. Now let's picture what happens in a London Dispersion force. We have, I'm going to write the steps first now. We have two separate molecules, A and B. Both are nonpolar, let's say. So there's electron flow everywhere. Now, this molecule approaches this molecule, and what will happen is that the electrons from molecule A will repel the electrons from molecule B. Sorry. Our step 2 would be that our molecule A is still nonpolar and has electron flow everywhere, but molecule B electrons moved away from the approaching molecule A. Sorry, I'm sorry about that. So molecule B electrons will flow away from the approaching molecule A. So this molecule will get polarized. The electrons will move away from the electrons from molecule A. And this side will become delta negative. This side will become delta positive. That's our second step. Now what happens now is that this delta positive charge is inducing a charge into molecule A. So it's polarizing molecule A as well. And let's go to our third step. So we had a polar molecule B before. This side was delta negative, and this side was delta positive. and we had a non-polar molecule A that is being polarized by the charges or the poles in molecule B. So this molecule then becomes delta negative right here. And now an attractive force occurs between these two. And those are London dispersion forces. And London dispersion forces occur to every molecule, remember that. So a quick summary. Ion-induced dipole is a force between an ion and a nonpolar molecule. The ion will, the charge of the ion will polarize the nonpolar molecule, and there will be an interaction between them. At dipole-induced dipole, we have a dipole that's polar, and a nonpolar molecule. The dipole, the charge on the dipole will polarize the nonpolar molecule. The pole on dipole will polarize the nonpolar molecule. So then we will have two dipoles, and one of the dipoles was induced, as the name says. London dispersion forces, we have two nonpolar molecules. The movement of the electrons, or the approach of the molecule with the electrons, will move the electrons away from one of the molecules. And then, because there's a pole now in one of the molecules, an opposite pole will form in the first molecule. And London dispersion forces occur to everything, and are the weakest forces. So those are the three induced intermolecular forces. If you found the video helpful, like it and share it with your friends.